Hello everyone, welcome to the study of second order quantile difference equation. We want to see how we can obtain the solution of a second order difference equation which is nonlinear and with constant coefficient a1, a2, a3. Now in this case, our Rx is sine of R. So what to do by what is called inverse operator. So first of all, you differentiate sine of Rx. This stands for differentiate. This one will obtain R cos of x. When you differentiate that one once, that will be the result. Then you differentiate it twice. D squared sine of Rx means you differentiate this again, so you have negative R squared cos or sine of Rx. When you differentiate this again, you will get that value. You differentiate this again, D3 sine of Rx, which will be negative R cubic cos of Rx. D power 4 sine of Rx, which will give you the following. This will become R squared, R power 4, sorry, sine of Rx. When you differentiate it 4 times, which can be written as negative R squared, you square this, sine of Rx. So that is the value we obtain. Then D power 5 sine of Rx is equal to R power 5 cos of Rx. Cos of Rx. The next one is D power 6 sine of Rx, which is equal to negative R power 6 sine of Rx, which can be written as negative R squared cubic sine of Rx. Now from that, we can generalize, whereby now we have f of D squared is equal to f into bracket of negative R squared from all this part we have obtained there. Meaning that now f of D squared is equal to f of R squared that way. Now in terms of sign, it means that f D squared of sine of Rx is equal to f bracket R squared when you sine of Rx from this fact up there. So if, which follows that 1 over f D squared sine of Rx is equal to sine of Rx divided by f of R squared x, that part there. So it means that if you have f of dy is equal to sine of Rx, it implies that our particular part yp will be given by sine of Rx divided by f D squared, which is equal to sine of Rx divided by f of R negative R squared. Basically, that is how we obtain particular part when our Rx is equal to sine of Rx. So, thanks so much. Also, similarly, when you have Yp is equal to cos of Rx of f of d squared by d operator, which is equal to 1 over f of negative r squared cos of Rx. So you substitute your R in D and you obtain your result. That is how the particular part is obtained in those simple method steps. So thanks so much. Join me for examples so that we may learn together.